yesterday, right, we started section 2.6 on combining functions, and we ended in the middle of page 2, and we had just started talking about composite functions. Composite between two functions f and g. Okay. So in example 3, right, we have f of x is equal to 2 over x plus 3, and g of x is equal to 5 minus x. Okay. And so we did A. Right, we found the composition between f and g as a function of x. And we showed that that is equal to 2 over 8 minus x. Okay. In B, we're reversing the composition. We're taking the composition of the function g with f. So now we're finding g of f of x. And so the first step is to replace f of x with what it's equal to. And f of x is equal to 2 over x plus 3. This is equal to g of 2 over x plus 3. Okay. Now how do we evaluate g of 2 over x plus 3? Well, we replace x and g of x with 2 over x plus 3. And we have 5 minus 2 over x plus 3. Now to simplify this, we need a common denominator, right? The only denominator is x plus 3. So 5, right, same as 5 over 1. We multiply top and bottom of 5 over 1 by x plus 3. We have 5 times x plus 3 minus 2 all over x plus 3, right? I did 2 steps at once. I multiplied top and bottom of 5 over 1 by x plus 3. And then I combined the numerators. So I have 5 times x plus 3 minus 2 over x plus 3. Okay. And now when you distribute the 5 inside the parentheses, and then simplify the numerator, you end up with 5x plus 13 over x plus 3. Okay. So, just to remind you, okay, how I went from this step to this step is we put in, we evaluate g of 2 over x plus 3, right? We just put 2 over x plus 3 in for x on the right hand side of g of x. Okay? And then we simplify. All right, any questions on that? All right, so now let's take a look at C, where we take the composition of the function f with itself. We can do that. Composition of f with itself is equal to f of x. In the first step, replace the inner f of x with 2 over x plus 3. So this is equal to f of 2 over x plus 3. And now to evaluate f of 2 over x plus 3, we replace the x on the right-hand side of f of x with 2 over x plus 3. So that is equal to 2 over 2 over x plus 3 plus 3. Okay? That is a complex fraction. Fraction inside of a fraction, right? So we gotta say this is the main fraction bar. So we gotta simplify the main denominator. And the main denominator, right? The common denominator between 2 over x plus 3 and 3 is x plus 3. So we gotta multiply top and bottom of 3 by x plus 3. And we have 2 over 2 plus 3 times x plus 3 all divided by x plus 3. Again, I'm doing 2 steps at once. I multiply 3 is the same as 3 over 1. I multiply top and bottom of that by x plus 3, and then I combine the numerators. I have 2 plus 3 times x plus 3 over the common denominator of x plus 3. Okay? I'm doing 2 steps at once. So now we got 2 over this fraction. And you know, when you do division with fractions, right, you keep the first number, you switch division to multiplication, and you flip the second, and then you flip the second number, right? The second fraction. So it's going to be 2 times that fraction flipped over. Okay. So this is equal to, maybe I'll write it down, an extra step. But with time, with practice, you get really good at this. So we have 2 times the reciprocal, okay, of this fraction, which is x plus 3 over 2 plus 3 times x plus 3. When you distribute the 3 inside the parentheses, you have 3x plus 9. So that simplifies to 3x plus 9. I forget something. Oh, plus 2, so it'll be 3x plus 11, right? So we'll have 3x plus 9 plus 2, which is 3x plus 11. Okay. So this 2, mind you, can be written as 2 over 1. So when you multiply 2 quotients, right, you just multiply straight across, and you end up with 2 times x plus 3 over 3x plus 11. Okay? If you don't see how I got this, right, you should, yes ma'am?
Can we go even farther as to simplify the top of the fraction when giving you the solution?
You need to distribute the 2, or if you want to.
Okay.
Yeah. Okay. I didn't feel the need to.
No.
But you can if you want. Okay.
What'd you say happened to the 2? When you after you, like when you,
This 2 up here,
no, the one,
here, 2 plus 3 times x plus 3. When you distribute the 3 inside the parentheses, you end up with 2 plus 3x plus 9. So you end up with 3x plus 11.
Oh.
Okay? Okay. Any other questions? Okay. You should convince yourself either I'm correct or I'm wrong. And if you think I'm wrong, right, come point it out. Got any questions on that? Alright, so in D, we gotta find the composition of G with itself. So that's equal to G of G of X. So again, right, so we replace G of X inside here with what it's equal to, and it's equal to 5 minus X. So we have G of 5 minus X. Now to evaluate G of 5 minus X, we put in 5 minus X in for X up here. We have 5 minus 5 minus X. So now you gotta distribute the minus sign, right? Inside the parentheses. And we have 5 minus 5 plus X, which is just equal to X. Any questions on that? Okay. In E, we gotta evaluate the composite of F with G at X equals 2. Okay. So there are two ways to do this now. Okay. One is we calculated the composite of F of G as a function of X. So we just plug 2 in and for X on the right hand side here. Okay. Replace X with the number 2. And we have 2 over 8 minus 2, which is 2 over 6, which is 1/30. Okay? Since we had already calculated the composite of F of G as a function of X, we can evaluate that composite at X equals 2. Yes, ma'am?
For D, wouldn't that be a negative X?
Well, we have 5 minus X in parentheses, right? So when we distribute the minus sign, we have plus 5 becomes minus 5, and minus X becomes plus X. A negative of a negative is positive. Okay? All right. The other way of evaluating this is this is equal to F of G of 2, right? A definition. We just find F of G of 2. Well, what's G of 2 equal to? Put in 2 in for X and G of X. You have G of 2 is equal to 5 minus 2, which is equal to 3. So you replace G of 2 with what it's equal to. It's equal to 3. So now we have F of 3. What's F of 3 equal to? Put in 3 for X on the right hand side of F of X. You have 2 over 3 plus 3, which is 2 over 6, which is 1/3. We get the same answers up here. There should be no surprise. Okay. Any questions on that? All right, flip over your page to example 4. we're given f of x is equal to x squared minus x. G of x is equal to 3x plus 5. And h of x is equal to the square root of x minus 3. Now we gotta find f of g of h of x. Okay. I like to use lots of spaces when writing these things out. Remember, you gotta have the same number of left-hand parentheses as right-hand parentheses or something's wrong. So first thing, substitute for h of x, right? That's the most inner function. So what's h of x? Square root of x minus 3. So this is equal to f of g of square root of x minus 3 and now we evaluate g of square root of x minus 3. So to do that, you replace x on the right hand side of g of x with square root of x minus 3. We have f of 3 times the square root of x minus 3 plus 5. Now we got to evaluate f of 3 times the square root of x minus 3 plus 5, right? So to do that, you got to put 3 times the square root of x minus 3 plus 5 in for x on the right hand side of f of x. So we have 3 times the square root of x minus 3 plus 5 squared minus, in parentheses, 3 times the square root of x minus 3 plus 5. Okay. All right. So remember those formulas on the first page of section 1.5? Was it 1.5? We had all those formulas. Difference of cubes, sum of cubes, difference of squares. Okay. But we had the binomial expansions, right? For n equals 3 and n equals 2. So this is a binomial expansion for n equals 2. And what we're actually doing, we're just foiling 3, what's in parentheses, times itself, right? So what we're going to end up doing, binomial expansion, is foiling 3 times the square root of x minus 3 plus 5 times itself. Okay? That's the binomial expansion for n equals 2. Okay? So when we do that, we square the first term. 3 times the square root of x minus 3 times itself. Okay? And when we do that, okay, we get 3 squared is 9, and square root of x minus 3 squared is just x minus 3. Okay. So when you square this first term inside parentheses, you get 3 squared, which is 9, and square root squared just leaves you with x minus 3. Then you multiply these two terms, and then double it. Okay. When you do the inner and the outer, you get the same thing. 15 times the square root of x minus 3. You get that twice. When you add them together, you get 30 times the square root of x minus 3. Okay. So we have then 30 times the square root of x minus 3. Actually, I'll write it out for you. 15 times the square root of x minus 3 plus 15 times the square root of x minus 3. Okay? So this is first terms, outer, inner, and now when we multiply last terms, 5 times 5, you get 25. Right? Last terms is 5 times 5 in the binomial expansion. Okay? And now when you distribute the minus sign inside parentheses, you have minus 3 times the square root of x minus 3. And then plus 5 becomes minus 5. Yes, sir?
So how did you get the 9 times x minus 3?
Okay. So we multiply first terms. You have 3 times the square root of x minus 3 times 3 times the square root of x minus 3. Doesn't matter what order you do the multiplication. 3 times 3 is 9. And square root times square root is just x minus 3.
And then the 15.
Is then you do the outer. You get 5 times 3, right? When you do the inner, you get 5 times 3. Right? And then you gotta do the last. 5 times 5 is 25. Right? So all I did was FOIL. F-O-I-L. Okay? That's all I did. Was FOIL. You with me? Now you gotta combine like terms, right? So we only have one term with x minus 3. So we have 9 times x minus 3. And then we have the like radicals. You know, this, you've heard of like terms. These are what are called like radicals, right? They're all got square root of x minus 3, right? So they're like terms. 15 plus 15 is 30, and 30 minus 3 is 27. So then we have plus 27 times the square root of x minus 3. Okay. And then lastly, we have the constants. 25 minus 5, which is 20. So that's the composition. F of G of H of X. I'll have to go through. Okay. Yes, ma'am.
Why would you not distribute out the 9 with the 9x minus 3?
I guess you could if you wanted to.
Okay.
Yeah. I stopped. Whose phone? Oh, me. It's from Oakland, New Jersey. I know absolutely no one from Oakland, New Jersey. Okay. I just love these spam calls. Okay. All right. Yeah, I guess you could have. Right. I just didn't go that far. Right? You could have done 9x minus 27. Then you have 9x, and then minus 27 plus 20 would be minus 7. Yeah. I just happened to stop there. Okay. All right. Any other questions? Okay. So does everybody understand? Like combining like radicals is like combining like terms. Okay. All right. So an example. Let's put my paper over. Example 5. Right. You're given f of x and g of x. And we gotta find and simplify the following.
That's 6.
Oh, excuse me, I'm blind without my glasses. Blind with them and blind without them. Yeah, 5. Alright, so now, you know how to take the composition of two functions. In example 5, we're doing a decomposition. We're going in reverse. Okay? So we have f of x is equal to x plus 2 squared or cubed minus the absolute value of x plus 2. Okay. So we need to find two functions, f of g and g of x, right, such that the composition of these two functions is equal to this up here on the right hand side. Okay? Yes, ma'am.
Where it says f of x, would it be f of g, or did you mean right f of x?
I meant f of x.
Okay.
Yeah. And I meant g of x. Okay. So in all the examples we did where we took composition of f and g, right? We had f of x is equal to this and g of x is equal to this. So we gotta come up with two functions, what we call two non-trivial functions, where that the composition of those two functions is equal to this on the right hand side. Okay? Is equal to x plus 2 cubed minus the absolute value of x plus 2, right? Well, big F of x is a function of x, right? But if you look closely, and this is sort of the key, it's also a function of x plus 2. Okay? Because we have x plus 2 cubed and the absolute value of x plus 2. G of x in the composition here is referred to as the inner function because it's inside f. And little f is called the outer function. So the key is to find a function of x inside big F of x that you can set g of x to. And then you replace that with x up here, and you now have the outer function. Okay. So if you look closely, big F of x, right, it is a function of x, but it's also a function of x plus 2. So we could set our inner function g of x equal to x plus 2. And then to find the outer function, f of x, what you do is you replace x plus 2 with x. And that gives you the outer function. Okay? So when you replace x plus 2 here with x, you end up with x cubed. And then when you replace x plus 2 inside the absolute value bars with x, you end up with the absolute value of x. So in that step, in getting the outer function, we replace x plus 2 with x in big F of x, right? I made my inner function x plus 2, and then I replace x plus 2 with x to get the outer function, okay? Does this work? How do you determine whether it works or not? Well, you take the composition and see if you end up with the big F of x. So the composition, right, so this is our, should write, this is our check that we're doing. the composition of f with g as a function of x is equal to f of g of x. What's g of x? X plus 2. And now when we evaluate f of x plus 2, what do? You put in x plus 2 in for x in f of x, right? And so when you replace x with x plus 2, you have x plus 2 cubed minus the absolute value of x plus 2, and that's equal to big F of x. So it checks, okay? It works. So there's no magic formula, right? You have this by inspection. You look at this, and you look for a function of x inside big F of x that you can set to the inner function g of x. And then you replace that inner function g of x with little x to get the outer function. Okay. All right. So any questions on that? All right, example 6 now. All right, we're given f of x and g of x. F of x is equal to square root of x minus 1, and g of x is equal to 2 over x minus 3. In A, you gotta find the composition of g with f as a function of x. So this is equal to g of f of x. F of x is equal to square root of x, right? So that's the first step. Replace f of x with what it's equal to. So we have g of the square root of x minus 1. And now to evaluate g of the square root of x minus 1, we replace x on the right hand side, g of x with square root of x minus 1. And we have 2 over the square root of x minus 1 minus 3. And I didn't go beyond, you could rationalize the denominator and what have you, but this is far enough, okay? In B, to find the composition of f with g, which is f of g of x. So again, g of x is the inner function, so we replace it with what it's equal to. It's equal to 2 over x minus 3. F of 2 over x minus 3. Okay. Now you evaluate f of 2 over x minus 3. Replace x on the right hand side of f of x with 2 over x minus 3. And we have the square root of 2 over x minus 3 minus 1. Okay. All that is under the radical, right? So now to simplify, we need a common denominator, and common denominator is x minus 3. So this is equal to the square root 2 over x minus 3 minus x minus 3 over x minus 3. Okay? X minus 3 divided by x minus 3 is 1. Alright. And so now, you gotta distribute the minus sign, right, inside the x minus 3 in the second numerator. And when you do that, you have 2 minus x plus 3, right? Now we can combine the numerators because we have a common denominator. So when we distribute the minus sign, we'll have 2 minus x plus 3 all over x minus 3. And then the numerator simplifies to 5 minus x. So this is equal to square root 5 minus x over x minus 3. Okay? Any questions? Disagreements on that? Okay. All right, the domain of fog of x, domain of f of x, okay, in interval notation. Well, the first thing we need to know is the domain of g of x, the inner function. Well, g of x is equal to 2 over x minus 3. There's one real number that's not in the domain of g of x. What is it? 3, right? Because you put in 3 in for x, and the denominator you have 3 minus 3, which is 0. Okay? So the domain of g of x can be written as x cannot equal 3. So 3 is not going to be in the composite because g of 3 is undefined. Okay? G of 3 is undefined. Put in 3 in for x, you get 2 divided by 0, which is undefined. Okay? So 3 is not going to be in the domain of the composite. Okay? The domain of the composite, f with g as a function of x, right? We have this radical, right? And you know that in the domain, the function involving square root, the radicand has to be greater than or equal to 0, right? It can't be less than 0. Because if the value of the radicand is less than 0, you're taking the square root of a negative number, and the square root of a negative number is not real, it's imaginary, okay? So, the domain of the composite, 5 minus x, the radicand over x minus 3 has to be greater than or equal to 0. This is like an exam 1 question, right? Solving this inequality. Okay? This is a rational inequality. And so, to solve that, you got to use, you guys I think like to call it the table method. I call it the test point method. Okay? Remember when we had the test points for each of the different intervals? So the first thing you got to do is split up the real number line into intervals, right? But you set the numerator equal to 0 and solve for x, and you get 5. You set the denominator equal to 0, solve for x, and you get 3. And we know 3 is not in the solution set, right? Because it's not in the domain of g of x, and it's certainly not in the domain of the composite function. Okay. 5 is in the solution set of this rational inequality because it makes, right, this equal to 0, and 0 is equal to 0, right? Our inequality sign is greater than or equal to 0. And now you got to do the test points from the 3 intervals to see whether it makes this positive or negative, right? So if you put in 0, right, 0 is less than 3. You put in 0 and for x, you have 5 minus 0, which is 5. 5 over negative 3, which is negative, right? So none of those numbers less than 3 satisfy this inequality. Then you had the interval from 3 to 5. 4 is in there. When you put 4 into the rational expression, you have 5 minus 4 over 4 minus 3. That's 1 over 1, which is positive. So any number greater than 3 and less than 5 makes the left-hand side greater than 0. So these numbers work. And then 6 is greater than 5. We put in 6 in for x. You have 5 minus 6 over 6 minus 3. So that's equal to negative 1/3. So any number greater than 5 makes the left-hand side up here less than 0. So the only numbers that work are greater than 3 and less than 5. And so the domain of the composite of f with g in interval notation, parentheses, 3, 5, bracket. That's the domain of the composite function. Okay? Any questions? Yes, ma'am.
What is 5 minus 6 be negative 1? Oh wait, I read that wrong. Never mind.
Right? Okay. Would not be unlike me to make a math error. Don't hesitate to say something. Alright, now we gotta find the domain of G with F in the composite. So this is D. We're going to find the domain of G with F. G of F of X. Right? So first thing we want to know is what's the domain of the inner function, F of X. Well, F of X, I think I erased it, is equal to the square root of X minus 1, right? So square root, radicand, by domain radicand has to be greater than or equal to 0, right? So the domain of f of x is the radicand x minus 1, has to be greater than or equal to 0. This is a linear inequality, we just solve for x. Add 1 to both sides, and we get x has to be greater than or equal to 1. So that's our initial restriction on the domain of the composite function, okay? F of x is undefined for any number, for any x less than 1, okay? You put in 0 in for x, you have 0 minus 1, which is negative 1, and the square root of negative 1 is not real, okay? It's imaginary. All right. So then, now we find the domain of the composite. And did I erase? So we wrote the composite in A, okay? Composite of G of f of x in A is equal to 2 over the square root of x minus 1 minus 3. Okay? So the composite has the additional restriction that the denominator can't equal 0. Right? Because any value of x that makes the denominator equal to 0, you get 2 divided by 0, which is undefined. Okay? So we have the additional restriction that the denominator, square root of x minus 1 minus 3, can equal 0. So not only does x minus 1 under the radical square root have to be greater than or equal to 1, but this denominator can equal 0. So now when we solve for x, right, we add 3 to both sides. The square root of x minus 1 can't equal 3. And then when we square both sides, we have x minus 1 can't equal 9. And when we add 1 to both sides, we get x can't equal 10. Okay. So there are two restrictions in the domain of the composite function. Okay? X is greater than or equal to 1, and x can't equal 10. Those are the two restrictions. Okay? I know this is a lot to grasp, but are you following? I hope you're following. Okay? Now we can graph this solution set before we write it in interval notation. X greater than or equal to 1. So here's 0, here's 1, here's 2, and then out here, here's 9, 10, and 11. Okay? So x greater than or equal to 1, you put a closed circle on the 1 and shade everything to the right. Correct? But then x can equal 10. So here at 10, you got to add an open circle. And that's the graph of the domain. Okay? X greater than or equal to 1, and x can equal 10. And now you got two intervals you have to join together with a union symbol. The first one starts at 1 bracket 1, and goes to 10 parentheses, right, because the open circle. And then you join to that left parentheses 10 to infinity. And that is the domain for the composite of G with F. Okay? So it's sort of a two-step process. First you find the domain of the inner function, see what its restrictions are, and then you find the additional restrictions on the composite. Okay? And those two together give you the domain of the composite function. Okay? All right. So what do we go to, 11 o'clock? 10:40, so you want to take your quiz? Call it a day? Okay. And we'll finish up page 4 tomorrow. Okay. Page 4 is a little lighter pair than what we just got done with the domain function. And so the numbers on the quiz are all straightforward numbers, nothing radical. Okay? So when you're done, the only thing you have out is a writing utensil. Freehand one. Front and back.